Here we have a brilliant device, again, almost 40 years ago. Look at the input and output. Test it over and over again.
We're at the home of Mr. Sparky Sweet. This is 15 May, 1987. And we're showing here the conditioning setup to actually make the vacuum triode, to make the pump waves and establish them in the permanent magnet itself, to make a permanent magnet vacuum triode. And so you can see here the large coil, which we'll focus in on here a little bit, and the large upright coil here. Inside this large coil, if we can go in there and see, there is another coil which we're not going to be able to see with that light, but it looks about like a spool of wire like this. I get on it here like this. It's an entire spool of wire. Number 15 wire, Sparky?
Number 15 wire with a DCR of approximately 4 ohms at 20%.
Okay. About a 0.4 ohm impedance. Number 15 wire, a whole spool of it, is sitting inside the large conditioning coil down on the bottom. Right here we see the SCR as part of the circuitry. There's a light bulb that gives him an indication of the voltage across the capacitor. Here you see he's reduced this conditioning circuit to using only one capacitor. What's the capacitance of that?
This is 1600 microfarad.
That's a 1600 microfarad capacitor. 250 volts. AC working voltage. DC working voltage. And he has a variac trigger arrangement set up and a potentiometer to adjust the circuitry.
Which we're doing now.
Which he's now doing, as you'll see by the light bulb. And there is the capacitor, the large tuning coil, or conditioning coil with the coil on the bottom.
The coil on the bottom is driven by wave-tech oscillator.
He has a wave-tech oscillator driving the coil inside at the bottom.
Through a 100-watt amplifier.
Through a 100-watt amplifier.
Okay. And this determines the natural frequency of the molecular structure.
That's the one that you impress in there, right?
That's the one.
When we open the gate in the molecular structure of the domains, whatever frequency we impress with that inside bottom coil is the frequency that's put into the magnet as a memory. In other words, that determines the actual frequency of the pump wave. You might say a cathode to plate oscillating current is established inside the magnet. And by analogy, that's what's established to make a vacuum triode. There's a capacitive discharge system attached to the large coil. It's being triggered by the variac, and as Sparky is pointing out, that is going...
This determines, of course, the time. This sets the time constant.
Right. This sets the time constant of that, and that's going to determine the gate opening in the triode.
Which is R times C.
Which is R times C, the RC time constant.
Right. Which is, of course, the resistance of the coil. And capacitance, capacitor, and farad. The resistance of the coil in ohms. And, of course, the time will be in seconds.
Xabel of the large coil is in ohms, and the capacitance is in farads, and of course the time is in seconds for the RC time constant.
Which in this experimental setup, this particular magnet is supposed to be approximately 10 or 11 hertz, right?
In this magnet, the resonant frequency of that magnet can be shown to be in the vicinity of 11 hertz. Now, each magnet will vary a little bit, and you must find the actual frequency for each individual magnet. But it's around 11 hertz for the size magnets we're using right now in the demonstration device.
And that's determined by see, can you shut that off for a second?
Yes.
Get in there.
Okay, here we have placed one of the magnets on top of the large coil,
Maybe I can get that to move.
and we're tuning the driver frequency down towards the 11 hertz. This is on the inside coil we're driving now. And when we get down to the resonant frequency of the magnet, you will see the lamination that's been placed on top of the magnet start to vibrate. You'll see it shake and oscillate a little bit, just at the frequency that is the resonant frequency of the magnet. Do a little adjustment.
Well, now you're making adjustment. Make it move.
This is the amplifier. He's tuning the amplifier voltage.
That's the sign. Oh, wait a minute. took the oscillator out.
Okay, now it's going.
Let's see if we can get that going there.
See if we can get it adjusted right on the resonant frequency.
Just hang on.
Let's see a little lamination wiggling when we hit it just right.
Check that down a second.
Yeah,
There it is.
there it is, right? Yeah. You want a resonance, right? Right there.
Move it.
There it
Really
is.
That thing's really moving.
Now the magnet is in resonance, and so we have the proper
That's
frequency
12,
to resonate the
about
magnet.
12 and a half.
This particular magnet is resonating at about 12
You were right about
hertz.
this part. Each one's different.
Each magnet is a little bit different, even though
Let's see
they're
if
the
we can
same
get it
size.
going a little better. No?
That's good.
No, it's really going there, okay?
That's in good resonance now.
Okay, now you want it absolutely in perfect resonance, right? There you go.
There's the
That's
best resonance
12
we can get, and that's
12 and a
fine
half.
right there.
All right, now let's see.
It's at 12 and a half hertz.
Right.
With the magnet in resonance at its 12 and a half hertz resonance,
There you go.
Now, gotta bring this up to the stop.
then we bring up the trigger
About
circuit
60,
at 60 hertz,
right?
which is being applied to the large coil.
Yeah, now it's stopped.
And there we are. You can see
Yeah,
the
yes, just
magnet in
wavering in
resonance.
between.
It should be.
Okay, that's 12, 13 hertz.
At 13 hertz, we now have a maximum in this magnet, as you can see right here.
So it's a little-
We've shown the first part of the conditioning process to condition each magnet individually. And now, the
I see what
entire,
you say, you have to condition this.
the entire magnetic assembly must be conditioned.
And then you put the whole thing
And so, as you can see,
Otherwise, you won't know where you're at. Wait.
in. No.
now as you can see, Sparky has assembled the two magnets over the aluminum box that is the holder,
And this is in positive mode.
and the ends must be kept in the same direction they were in when they were conditioned before.
Tractor mode. And we put this in
And they're in the attractive mode. They're then placed in the box inside the large coil, sitting down on the other coil, so they're about in the center of the large coil. They're approximately centered in the large coil. With the box in that position, then, the final conditioning process is ready. At this point, you can hear the chattering as the beat frequencies go. Pump waves are going. And all that remains to be done is to turn on the 10 hertz, 10 volt, 60 hertz driver signal.
Nothing's moving.
And at that point, now see, your driver signal is in the small coil this time, right?
Yeah, that's the small coil, 10 volts, and, well, in the case of the one we have inside is, now, this is on.
Right, so it's locking.
It's on. Now
Bottom
you
coil
hit
is
it-
on.
Now you hit it with the frequency.
And that's it.
That's it.
That's it. You can load the coils and go.
Go.
Just hit the big coil with the frequency, right?
That's
Yeah.
it.
The pulse.
And that's it. You know,
That's it. At that point, the conditioning is finished, and you now have a permanent magnet vacuum triode, the incredible invention of Mr. Sparky Sweet. This is May the 15th, 1987, in the home of Mr. Sparky Sweet in Sherman Oaks, California.
very distraught lady who's Sparky's wife. She's saying Sparky's dead. And that she said two strange men, she called them strange men, showed up at about 5 o'clock the night before, and they stayed for a little while, and then they left. And Sparky, an hour or two later, having a cup of coffee and just keeled over onto the floor, called the ambulance, and she was 75 years old. They would not let her in the ambulance. And the ambulance then called her back about 20 minutes later and said, "We don't think he's going to make it." And that was the end of that until the next morning when she called my sister-in-law and talked to her and said, "There are men here that said they're FBI, and they got black vans, and they're taking all this equipment. What should I do?"
So we have a 120 volt fan. As you can see, it's turning at good power. It is providing quite a breeze, and it's real, usable power. Now we'll turn around, and here is just coming into view, you see 5 100 watt lamps, ordinary garden variety household lamps, brilliantly lit. So there's 500 watts of very real power here, again coming right out of the vacuum. And you see the assembly of very large meters and show you the kind of power amplification that is being achieved by the vacuum triode.